Thank you, Russ, and thank you for inviting me along. Yes, this is a campaigning conference, so I hope to maintain that campaigning element, although it's a pleasure to follow Vaughan and Chris's presentations, which really give an excellent overview of the fantastic work, really quite long-standing work that's going on in the UK at both Pontbrenne and Allerton and other locations. Really effectively in terms of addressing these quite profound agricultural problems causing me as a fisherman virtually a lifetime's angst at the very least, seeing the catastrophic decline of salmonids and eels in the UK, absolutely in my mind associated with the use of agrochemicals since the 1970s, and those very same chemicals also associated with the destruction of soil carbon and the agricultural practices involved in using those chemicals. I've been asked to speak primarily today on those things that farmers can do here and now. I'll try and keep the rhetoric to a minimum, but there is a context here, and I would just like to expand a little bit on that context. Of course, I think now we all broadly accept, even many of the most hardened skeptics, that climate change is a severe issue. Frankly, you've only got to glance at that CO2 hockey stick curve to see that terrifying upward curve. Despite that, we seem to be struggling to fix this issue. We seem somewhat confused in terms of whether we're dealing with causes or effects. And part of that confusion, I feel, is what are the tools to be used. Chris has focused probably more on the wider farming context, and so also today we've heard from earlier on people like Elaine Ingham really expanding on a wholly different agriculture, soil carbon farming, where maintaining or preferably increasing carbon and humus in the soil must be the way forward in at least addressing some of both the causes and effects of climate change. Sadly, it's taking time. Those familiar with biodynamic farming practices and their mysterious ways perhaps have had a longer-term understanding of these issues, but the science is still being evolved. And similarly, in terms of the work that's being done at Pontbrenne and Allerton, we are defining essentially new policy processes here for DEFRA and the other regulatory agencies to get behind. This takes time. We're all locked into our own positions, whether we're individuals out there essentially as a campaigner, which I am, or working in a regulatory agency. One senior environmental regulator said to me, we're a supertanker slow to turn. These are fundamentally cultural issues. But as a farmer or landowner, yes, you are very much hemmed in, just the same as everyone else, but you do have that little bit more freedom to bring about change within your own domain. And if you think of yourself as an holistic farmer, where taking responsibility for your land should be a cornerstone of your practice, then taking some responsibility for what goes on outside of your land should also be a very important part of your thinking. So those key tools, catchment water balance, that's primarily attenuation, holding water within the catchment. What we've done through at least 50 years of farming practice and urban development is to accelerate the water cycle. We now have to start slowing it up by holding water. As I've mentioned, soil carbon farming, and two other criteria, public health and biodiversity gain. I'll try and touch on these in the remaining quarter of an hour or so that I have left. Dave's here in the audience with us, Dave Stanley, a man with both farming and senior environmental regulatory experience. And he put it quite clearly. He tells me this isn't his own quote, but dates back to Roman times. It's the 3 M's, he says, we need to apply. There is no empirical determination or management of landscapes according to soil, carbon, humus content. Okay, it's an evolving science at the moment. Disturbingly, from my point of view, there is neither an empirical determination for rainwater storage or attenuation water balance in the landscape. These are key regulatory failures. It may also disturb you to know that we have no public health standards for our watercourses or the discharges into them. I gave up a career serving the water industry and agriculture 30 years ago when I realized that the muck spreading equipment that I was selling was dispersing pathogens into communities. I also realized that most river weirs on lowland UK rivers similarly disperse pathogens into adjacent communities every time it rains. These are very serious issues that are so often brushed under the carpet. Chris covered soil erosion, compaction, and runoff. Here's some of our own work in the Cotswolds. Just to explain what's going on here, we've got soil erosion, incredibly, up to 70 tonnes a hectare a year in the worst cases in the Cotswolds. We're told that Cotswold brash is a free draining soil. I'm sure it was once upon a time, but if you take all the good stuff, the humus out of it, and you run heavy vehicles over it and compact it, the runoff is greatly accelerated. The base flows in the rivers drop catastrophically. We know this actually from the data on the old hydraulic ram pumps that were installed a century ago. The base flows in our springs has correspondingly dropped by over 50% in the last century. Now we greatly oversimplify these phenomena, and the flip side of these, which is increased runoff and flood, as climate change. Yes, it is climate change, but primarily caused not by CO2 in the atmosphere, but lack of carbon in the soil. Incidentally, as a part of this postgraduate study, we found that the nutrient value as a fertilizer replacement of this material carpeting the beds of our local watercourses, destroying my beloved fishing at the same time, is worth £100, up to £100 a tonne as a fertilizer replacement. You're not allowed to spread this on the land, but where a few landowners have, they've reported best ever pastures as a result. So we need safe and viable plans for water everywhere. The Water Framework Directive, a brilliant piece of EU legislation, does encourage this to happen. It's evolving slowly. This is an early schematic looking at probably the first catchment-based approach proposal in the UK. It's 20 or so years old now, and I'm thrilled to see much work aligned with this taking place in the UK. Major flood events do look unmanageable. The media obviously only ever shows us the worst, and if you're living in a property at flood risk, and 1 in 6 of us do, yes, the force of nature, act of God, it seems unstoppable. Well, at the moment, by not applying any empirical measures to any great degree in trying to fix flooding, of course, we're going to have ever-worsening floods. The science, the technology, the farming practice to resolve these, and I believe largely control them, not just here in the UK, but conceivably even worldwide, is there. I'll explain some of the hydraulic modelling that we've done in the next few minutes. This can be done by a piecemeal approach, by everyone taking responsibility. But what are you taking responsibility for? How much water should you be storing? This first little case study is a local authority that took responsibility. So if I can make this laser pointer work, I'll try and explain what's going on here. This is Churchdown Local Authority's office, and you can see this area here, if that laser picks up, is the paved area around their offices. We've got a larger area here of playing field. The paved area is about 1/4 of a hectare. The playing field area is about 3 hectares and a small park. They were concerned that their stormwater was running off untreated into the local brook and contributing to local floods. They came to us because they wanted to store it on their land, and the first thing we did was look at the total annual runoff from the total rainfall, which at an annual rainfall is about 700 millimetres, was for the 2 areas, the paved area and the park area, in the region of 20-odd thousand cubic metres. But of course we couldn't and wouldn't want to store all of that, though that's a useful figure to have. What we were required to store here was the worst 1 in 100 storm event. So in order to estimate return periods of worst storm events, you consult something called the Flood Estimation Handbook. It's produced by Hydraulic Research at Wallingford. And in terms of the sizing of any such systems, what you're primarily concerned about, obviously, is the maximum likely volume of water that you're going to get. And here we're working on a 12-hour period, as well as the maximum intensity of any storm. So you need to know the intensity of the storm in order to determine the diameter of the pipe work to handle the water. And then you need to know the total volume of water in that storm event in order to determine your storage. All perfectly feasible. I'm pleased to say that the scheme is in now and working. And from a farmer's point of view, in terms of the economics of this, this authority is now saving itself about £3,000 a year from its action of disconnecting itself from the local sewer. Diverting, actually. The connection is still there, but they've diverted now all their surface runoff. They're saving about £3,000, but that, remember, was just what they were being charged for the paved area. This system actually cost about £100,000 with a lot of goodwill. You may say, well, £100,000 expenditure to save just £3,000 a year is not a great return. But remember this, it was sized actually to take all the rainfall runoff from a 3-hectare area. So if that had been a supermarket car park covering a 3-hectare area, and you just might be a farmer adjacent to a supermarket car park, then you would be looking at vastly higher runoff charges from the water company, probably in the region of £30,000 to £40,000. And at that level, just the same investment, £100,000, makes a very quick return. It's a fascinating thing about the economics of water, that through what we're told is climate change, the cost of water, which for a farmer is a really pressing issue, whether it be for watering your livestock or just washing down, gets ever higher, and as a member of the public, just the same. We have this curious paradigm that a musician cousin pointed out to me. When we were younger, water was cheap, but music, his profession, was darned expensive. And I remember having to save up to buy an LP when I was a teenager. These days, music is virtually free. It's given away on the internet, but water is darned expensive. Well, the reason water is expensive is essentially because of our degradation of our landscapes, our acceleration of the water cycle. I can't comment to any detail on the cost of music. But anyway, this scheme was installed successfully. It's an example of public competition, a local authority basically competing with a privatized water company and taking the business back into public control. But similarly, it could be a private farmer or landowner doing the same thing. This was another early feasibility study. This was for full sewerage treatment. This scheme would, for just £25,000, actually have produced all of this village's energy in raw, unprocessed biomass, a population of 100 people. What they ended up with was a pumping station which cost £500,000, which wastes energy, and so on. But when you start to deal with a community as opposed to a single client, you then have to apply for an inset appointment from Ofwat. And what we found 20 years ago when we looked into this on that previous slide project was that the licensing fees for that inset appointment were going to be about as much as the cost of the scheme itself. So there are many, many barriers. Many of these barriers are just simply cultural. And I was asked during the course of my pitch here to give a bit of a plug for another session tomorrow, which I'm speaking at, which is at 2:00 in the long room. It's headed Drought, Floods and Farming. We're going to be looking at the history of how we got into this situation, as well as a little bit more on what farmers can do, and very specifically the cultural context that is delaying progress to what from an engineered perspective, are really quite straightforward solutions, although, as I say, the regulatory processes are lagging on. Now, I built some early reed beds. On this Churchtown scheme, we were required, because surface runoff picks up all sorts of contaminants, to put some reed beds in. But my early reed bed experience was not good. I thought it was just a matter of putting some gravel into place and planting a few reeds, and nothing could be simpler. I couldn't be further from the truth. Unfortunately, I did it on primetime TV, and many people went down that same route. There is a lot more to phytoremediation than I could have even begun to understand. There are many parallels between how an aquatic plant works and a dryland plant or a grass works, and you really need to be a scientist of the caliber of Dr. Elaine Ingham to fully understand and appreciate this. Now, I'm pleased to plug 2 UK companies who really do understand phytoremediation. There's Jay Abrahams of Biologic Design, now with over 20 years of experience, and you can see top right on the screen his scheme at Western Cider. And then also with even longer long-term experience, Oceans ESU, with over 30 years practice in the UK. Now, several key things about both these practitioners. They really understand, like Dr. Ingham, the microbiology and those processes going on below the surface. And they also have that sort of track record of many decades to really give reliable design. And I would suggest you only go to people like that. There may well be others. My apologies to them if I haven't mentioned them. I don't know of them. Oceans have been good enough to let me share some of their proprietary knowledge with you today. The microbial processes obviously take place in the root zone, and it is within the root zone that the full flow of liquid to be treated must pass. If it passes over the surface, it's not going to get treated to any great degree. It's important, therefore, that that bacterial living biobed of activity is fully taken up with the rhizome or root zone of the water plants that you're using. In terms of the typical depth of a reed bed, something around or upwards over 1/2 meter, really Phragmites is the only one that gives that full depth. I know that a polycultural approach can be used, and Biologic Design use that. Oceans don't. But here you can see on the lower left some of the typical root depths of the various water plants, all of which will provide cleansing, but the Phragmites gives that greater depth. It's important to also understand that there are over 90 different ecotypes of Phragmites. Each one hosts a different microbial population on its rhizome, and each one will give differing cleansing characteristics. I've got 2 minutes, and I've got quite a bit more to go through. So gravel really doesn't host the great degree of microbial activity. Soil particulates are best. This is really the key difference between the biologic and oceans methods. They primarily use soil. This confuses many other practitioners because when you plant up with soil, it works fine to start off with, it then very quickly loses its permeability. It's the secondary structuring that the Phragmites and other plants provide over time that then opens up the hydraulic pathways to maintain treatment. So to recap, we can resolve flood risk, and we can do it by largely restoring disrupted natural landscapes and neglected historical solutions. We've looked at a community-led approach. We've not only defined the hydraulic and empirical modeling for the first time in 2008, a great student, Ilaria Preto from University of Trento, did this. We've also been out there in the landscape, and to our surprise, find the majority of landowners, when you talk to them and ask them would they store floodwater to protect the people downstream, say yes. And of that majority, significant numbers say, actually, I've always wanted to store water on the land, but the authorities have stopped me from doing so. Here's a typical catchment study where we're actually able to store, on this analysis, 143% of a 1 in 75 storm event. I would suggest that flood management and drought management in virtually any river catchment in the UK is entirely feasible, and with the amount of misery that flooding causes and the need now to really move agriculture into a new sustainable, I prefer to say safe and cost-effective form, this is what we should be doing. Small hydro may have a role. We've heard mention of leaky weirs, attenuations, developing the catchment plan around a water and carbon balance model. I think I'm close to running out of time. So just to close, I would actually say that public health is the number one criteria for action. Almost certainly a lot of disease is being caused by our failure to apply that, and certainly a lot of other misery in our communities by really failing to apply an empirical approach. Collaborative goodwill, everyone working together at a community level is key to success here. Thank you very much.